solutions. And before I begin, let me just mention again that if you like enjoying videos like this or enjoy videos like this, please remember to subscribe. And other than that, let's just start with the next problem. So we see that we have solved 40 problems so far, and today we'll solve maybe one problem, and then we'll see you next time. So let's look at problem 41. Okay, so pan-digital prime, pan-digital numbers again. So we've solved many pan-digital numbers, and we are going to look at another pan-digital number problems. So this is problem number 41, and the title is called pan-digital prime. Okay, and then let's take a look at this. Let's take a look at what the problem is. Okay, we shall say that an n-digit number is pan-digital if it makes use of the digits 1 to n exactly once. For example, the number 2143 is a 4-digit pan-digital number and is also a prime. Okay, so it has to be pan-digital, it has to be a prime. Okay, what is the largest n-digit pan-digital prime that exists? Okay, so let me take out my so let's take a look at this. So basically what we're looking at is generally when we look at prime numbers, we tend to look at the sieve algorithm. So we create a sieve algorithm, and then we look at all the primes, and we find that we find which numbers are a pan-digital number. We can find the primes over here using the sieve algorithm, and based on this we can figure out whether a particular number is also pan-digital and look at the greatest number. The problem with this is that the pan-digital number let's say the 9-digit pan-digital number 1 2 3 4 5 6 7 8 9. So that's the 9-digit pan-digital number. We at least have to check for check 100. What is this? 3 6 and then so 100 million. We have to check 100 million numbers. So we generally check all the way up to a million, and that takes about 27 seconds. So this is going to go up exponentially as we go from 1 million to 10 million to 100 million. So I am guessing that there is another solution. I doubt that finding pan-digital numbers using this sieve algorithm is a very meaningful way of solving this. Just as a example, if I am solving it for a general case, then I will look at all primes and there are list of primes in Wikipedia, and you can just look up all the primes all the way up to or you can also look at what am I doing? List of primes up to this. So you can just download a list of primes, okay, and then use that. But that's and if I were solving a real life problem, that's something that I will actually consider using. But this is not a real life problem. This is a problem where you're supposed to find the solution. So there must be a better way of doing things. So what we can consider doing is that we can, so my idea is that we can look at a pan-digital number, let's say 1 2 3 4 5 6 7 8 9, and then check whether this is a prime. Why? Because there are significantly lower number of different entities that we need to check, and so we can check whether this is a prime. We can check whether so for example, let's say we start with a two-digit pan-digital number 1 2 and 2 1. Those are the only two one-digit pan-digital number 1, that is a prime. We don't care about this two-digit pan-digital number. Those are the only two possible two-digit pan-digital numbers. This is not a prime because it's 3 times 4, and this is 3 times 7. So it's I don't have to check for this. 3-digit pan-digital number 1 2 3 1 3 2 2 2 3 3. Then I have 1 3, then 3 1, then 2 1, and 1 2, something like that. So then this is something that I have to check, right? So 1 2 3 is, so this we don't care about. Then 1 3 2, this we don't care about because it's divisible by 2. Then for example, this one is, wait, this is divisible by 3 because 3 4s are 12 40. Wait, 3 and 2 5 and 1 6. Oh, so if we add the numbers 1 2 3, then we get the sum 3 and 2 5 and 1 6. So all these numbers are divisible by 3 because they are so I don't have to worry about this. What about 1 2 3 4? This is divisible by 2. Then this is sum of this is 10, so it's not divisible by 3. Then we can check. Okay, so I think let's first create a function that will check whether a number is divisible, is a prime number. So that's a, and the other thing is we can just eliminate everything where the sums add up to something that is divisible by 3. Okay, let's take a look. So range 1 to 10. Okay, and print list range 1 to I, 1 2 3 4 5 6 9. Oh, I plus 1, I plus 1, like that. And let's look at the sum. All these numbers are divisible by 3. I oh, this is not divisible by 3. Is this the only number? Oh, this is not divisible by 3. This is okay, let me see. Okay, so we don't care about this, we care about this, and then we care about this. So we'll start with this 7-digit number. If it's only a 7-digit number, we can find all the primes. Okay, never mind, we only have to check all the 7-digit numbers. Okay, so we just need to check all the 7-digit numbers. So and I think we'll find something over here. So okay, let's see. Okay, so what are we going to do? We are going to find all permutations of the 7-digit pan-digital numbers and then check whether it's a prime. Okay, so we'll write a function is prime that will take a number n, which is an integer, and return a boolean, and it is going to return a true if it is a prime and not true if it is not a prime. Okay, and how do we check whether something is a prime? For I in range from math import sqrt. I think math will have square root, so sqrt of 25 is going to be 5. all right, so I want everything all the way from 2 to int. Okay, how about I do a round? Okay, oh, how about 26? Ceiling, is it here? Okay, all right, ceiling square root sqrt square root of n. So we only need to go to square root of n. We don't need to go all the way out. So if n percentage I is 0, return false because it's not a prime number, else return. We go all the way down to the square root of n and it's not that, then we will say return true. It is a prime. Okay, so is prime 27, the answer should be false. Is prime, let's say 17, true. Okay, so is prime is something that works. The next thing that we want to do is create an iterator. Permutations of 7, 6, 5, 4, 3, 2, 1, because we are looking at this. This will give an iterator, let's say n equals 1000. Okay, I slice iterable and then stop, and let's go all the way to 1000 and check if there's a prime number in there. Okay, so let's look at the first 5. Ayo. Okay, this is giving me what I want. So now for v in value, v in that, okay, I want to convert it to an integer, so v equals int of join v, like that, and print v. Okay, now I just need to check whether these things are prime. If is prime, v, print v. Nothing, we don't have a prime. tq dm dot notebook import tq dm. Let's okay, now let's start increasing this. Let's say 1000. Wait, we already found a prime. Okay, This one should be the answer. 67652413. I think this is the answer. This was pretty simple. Okay. So well, this is it for today, and I will stop over here, and we will see you next time. How long have we? Only 20 minutes.